Let's see our first question. In the given question, we have to write an algorithm to accomplish the task for polynomial px given in the following table, where px is equals to an x power n plus an minus 1 x power n minus 1 plus an minus 2 x power n minus 2 plus an minus 3 x power n minus 3 so on plus a1 x plus a0. We have to perform three different tasks for evaluating polynomial px, dividing a polynomial px by x minus r, and find the derivative of polynomial px for iterative approach and recursive approach. Here, there is an algorithm for evaluating the polynomial px using brute force technique, which is also known as iterative approach. Firstly, we have to initialize the sum variable s to 0 for each term of the polynomial from highest to lowest degree. Then, compute the value of the term by multiplying the coefficient with x raised to the degree of the term. Then, add the computed value to the sum variable s, return the value of s as value of the polynomial px. Here's the algorithm for evaluating the polynomial px using recurrence relation, which is also known as recursive approach. If the degree of the polynomial is 0, then return the value of the constant term a0. Otherwise, compute the value of px recursively by computing the value of the polynomial of degree n-1 by calling the function recursively. With the polynomial of degree n-1 as argument, compute the value of the current term by multiplying the coefficient with x raised to the degree of the term. Then adding the computed value to the polynomial of degree n-1. Then return the value of polynomial px. Here is a program for the given algorithm. First, read x and an array a. Initialize the sum as 0 for I is equals to 0 to n in steps of 1. Do read ai. Then n for sum is equals to 0 for I is equals to n to 0 in steps of -1, where sum is equals to sum plus ai into a x power I. Then write the sum. Here is the algorithm for evaluating the polynomial using the recursive relation. Here, first we have taken a functional polynomial and initialized as int n, int x, and int array a. If thus n is equals to if n is equals to 0, we have to return a0. Else return an into x power n plus polynomial n minus 1 x int. We have called polynomial as we are using a recursive method. Then we have to read x and array a. Sum is equals to 0 for I is equals to 0 to n in steps of 1. Then read ai and print polynomial n, x, and array a. Here is algorithm for dividing polynomial px by x minus r. Firstly, we have to initialize the quotient polynomial q and remainder to 0. For each term of the polynomial from highest to lowest degree, compute the value of the current term of quotient by dividing the coefficients by x minus r. Add the computed value to the quotient polynomial q. Then compute the value of the current term of the remainder by multiplying the quotient of the term with x minus r. Subtract the computed value from the current term of polynomial, then add the computed value to the remainder polynomial r. Then return the quotient q and remainder r. Here, algorithm for computing the derivatives of polynomial px. Initialize the derivative polynomial d to 0. For each term of the polynomial from highest to lowest degree, compute the value of the derivative of the current term by multiplying the coefficient with the degree of the term and subtracting 1 from the degree. Then add the computed value to the derivative polynomial d, return the derivative polynomial d. Here is a program for dividing polynomial px by x minus r. Here, firstly, we have to read x, n, and array a, r. Initialize sum as 0 for I is equal to 0 to n in the steps of 1 to read ai. And for q is equal to 0 and r is equal to 0. Here q is quotient and r is remainder. For I is equal to n to 0 in steps of -1. Firstly, cq is equal to ai divided by x minus r. Q is equal to q plus cq into x power I. CR is equals to Q into X minus R is equals to R minus AI into X power R minus CR, writes QR. Here is a program for derivatives of polynomial Px. Here, firstly, we have to read X and A. Initialize sum is equals to 0. For I is equals to 0 to n in steps of 1, do read AI. And for d is equals to 0, here d is equals to derivative of polynomial d. For I is equals to n to 0 in steps of minus 1, cd is equals to ai into n minus 1. Here derivative is equals to d plus cd, right derivative.